So for this example, from the time Mark Twain wrote the celebrated jumping frog of Calaveras in 1865, frog jumping competition had been growing in popularity. The graph shows the function of y equals negative 0.029x squared plus 0.59x, modeling the height of one of the frog's jumps, where x is the distance in feet from the jump's start. Based on your in-depth knowledge of frog jumping, what would be appropriate window for the settings to use? So think about, can frogs jump very far? Right? Let me start myself. Markboard. So using our graphing calculators, let's go ahead and go to y equals and type this in. Negative 0.029x squared plus 0.59x. X squared plus, what was it? 0.59x. And hit graph. I'm going to hit zoom 6. Oh, syntax error, so I must have typed something in wrong. Oh, I used the negative, not the minus. Alright, so we can't see our entire jump, right? We can see where the frog started, but it went and we don't really see where it landed. So we have to change our window. So think about how far a frog can jump, and you might need a guess and check. So looking at our initial graph, our x-min is somewhere around 0. I would go maybe a little bit past 0 just to get a good window, but if you put 0, that's fine. The x-max is where the frog lands. So clearly it's going further than 10. So I would say maybe around 20, 25. We'll say 25, and we'll go by 5s. So y-min, again, it's at 0 because that's on the ground, but I would go maybe a little bit past 0, just so you get a good, better picture. And the y-max, as you can see when you look at the graph, it's about 3. So I would say the y-max is 5, just to have a nice count. And I'll go by 1s. Let's adjust our window in our calculator to match. So I'm going to go to my calculator. I'm going to hit window at the top next to y equals and change my window. I'm going to change that to negative 5. I said that was 25. And my scale is 5. I'm going to change that to negative 5. Change that to 5. Or negative 2. Honestly, I might change that to negative 2. And my scale is 1. And hit graph. As you can see, we have a much better visual. We can see how high the frog went, where it landed, and now we can answer the following questions. And sometimes you need to guess and check to get a nice visual window. So maybe you did 15, and then it didn't pop up if your x-max was 15, and it didn't pop up in your window. Well, then you know you need to adjust your window some more. Okay? So now we can use this to answer the following. How far did the frog jump? So to figure out how far the frog jumped, we need to figure out where it landed. And here's where it landed. So we can figure out where the frog landed, we can figure out how far it jumped, right? So to do that, we're going to use that 0 tool. So I'm going to hit second, trace, 0. Left bound. So as we're approaching that x-intercept from the left, we are above. So I'm going to go a little bit above and hit enter. Go below, hit enter, and then hit enter again. And that frog jumped roughly whatever the x-intercept is, 20.34 feet. That's a pretty far jump. 20.34 feet. Determine how high the frog jumped. We'll determine the height right? We need to figure out, well, what's the maximum? And specifically, what's the y value of that maximum? That will tell us the height. Where it landed is x, the height is y. So, again, we are going to use our calculator. We're going to hit second, trace, maximum. Go to a little bit to the left of the maximum. Enter. Go a little bit to the right of the maximum. Hit enter. And then guess. So it roughly jumped about 3 feet. Whatever the y value of that turning point is your answer. So it jumped about 3 feet high. And then it says, how high is the frog at 2.25 seconds? So we want to know, hey, how high was the frog at 2.25 seconds? In your calculator, what you can do is second, trace, and then value, and type in 2.25. And it's about 1.18 feet high at 2.25 seconds.